Right. So these are from the third 9 weeks, right? The 10 problems from the third 9 weeks relate to these problems here. And you could see the first set of problems, 269, 15, and 16, are finding coterminal angles, right? How do you find coterminal angles in radian measure? Add or subtract 2 pi, right? Add or subtract 2 pi. Remember, it's a multiple choice test. So, I mean, if you do things, if you turn things into decimals that they don't, like something that sometimes in the problems would say exact, do exact. I mean, if you don't do exact, you're not going to find your answer because the answers are exact, right? They have the square roots in them and things like that. And pi. Okay, 37 and 38. Okay, rewrite an angle which is given in radians into degrees. How do you convert from radians to degrees? Okay, 3 pi over 2, right? Multiply by 180 divided by pi, right? And you know, in this case, since you're going to degrees, I mean, you're going to turn it into a decimal. I mean, definitely. You're not going to have pi in the answer. Now, remember, when you're dealing with radian measure, radians are unitless. There really is no unit of a radian. That's why most of the time you don't see RAD after it. If you do, they're just trying to give you a hint, you know, that this is radian measure. Most of the time, how do you know whether they mean radian measure or degree measure? If it's degrees, it has a degree symbol. Anything else, even if it doesn't have a pi in it, is radian measure. Okay, so you could put all that in the calculator, get your decimal value right there. Next, page 277, 31 to 36. Evaluate the trig function using the period as an aid. What do they mean by that? Okay, so when they ask for this, what they're saying is, we want to use the unit circle to evaluate these functions. But the unit circle goes from 0 to 2 pi. And these are not 0 to 2 pi. So how are you going to get an angle in between 0 and 2 pi so you can use the unit circle, which, by the way, you need to know it's not going to be given. Get a coterminal angle. Like, for example, on the sine of 4 pi, if you didn't recognize it, subtract 2 pi. Okay, the sine of 2 pi, do you recognize that? Right? Where is 2 pi? Yeah. Right. 0, 2 pi, what is the sine? It's 0. The y-coordinate is 0. Right? So the sine would be 0. The cosine of 3 pi. Okay, 3 pi is not in between 0 and 2 pi. If I subtract 2 pi, right, now I'm taking the cosine of pi. Where is pi? Pi, right there. What's the cosine? -1, right? -1, the x-coordinate. So that's what they mean by this, right? These angles are not in between 0 and 2 pi. So find a coterminal angle by adding or subtracting 2 pi, and then you got to think of the unit circle. Okay, there will be there'll be a word problem, multiple choice, that has to do with angles of elevation. Right? This is, I said on there 67 to 69, but just, I'll put one up there, go through one. Right? You're standing 45 meters from the base of the Empire State Building. Right? So let me draw that. 45. And here's the building. You estimate that the angle of elevation to the top of the 86th floor is 82 degrees. Right. Angle of elevations, remember, angle of elevation, angle of depression is always with the horizontal. So this is the horizontal line, you know, from you standing at the base looking towards that. And so the angle of elevation would be that angle there. One side is the horizontal line. Okay, this is the 86th floor right there. And it says there's another 123 meters above the 86th floor to the top. Okay, what is the approximate height of the building? Okay, so the height of the building will be this entire thing. We know this piece of it. So what do we have to find? That. So now it's right triangle trigonometry, right? Which trig function will you use if the angle is here and the two sides involved are that side and that side? Tangent, right? This is opposite and adjacent. So you'll go tan of 82 is x over 45. Solve for x. And that'll give you whatever that value is. And then you'll know the entire height. Okay. And then it says, what is the approximate height of the building? Okay, one of your friends is on the 86th floor. What is the distance from you to your friend? Meaning, how will you find that? I mean, if you use a trig function, you could say the cosine of 82 is 45 over y, solve for y. But if you've already found that, what else could you do? Pythagorean theorem, right? So one way or the other. But angles of elevation, angles of depression, right? It's always with the horizontal. You're sitting in this right triangle trigonometry. Okay. This point is on the terminal side of an angle in standard position. Determine the exact values of the 6 trig functions. So let's take one which is, let's say we'll do this one right here, 16. Okay. First of all, well, let's just go like this. -4, 10. -4, +10. Okay, and we want to know the 6 trig functions. So this is -4, that is +10. What do we have to figure out before we can do that? Hypotenuse, right? Pythagorean theorem, right? This side right here is the square root of -4 squared plus 10 squared, which is the square root of 116. And, you know, that could be rationalized or simplified a little bit because that's 4 times 29. So that's 2 times the square root of 29. So once you've got all that, then you're going to use the SOHCAHTOA, right? The sine is 10 divided by that. The cosine is -4 divided by that. The tangent is 10 over -4. That's what you want to do with those. You know, for a lot of these things, you know, make sure you draw a picture. Right? Draw a picture. It's okay. Okay, then compositions of a function, a trig function, and another inverse. Right? If you remember, there was another kind of problem. That's not part of it. There was the kind of problem where it's the composition of a function, a trig function, and its own inverse. In a way, those are harder because those are all about domain and range of the trig functions and their inverses. They tend to be more complicating for us. Remember, in these kinds of problems, if you want to know what the sine is, when the sine of the arctangent of 3/4 is like saying, what is the sine when the tangent equals 3/4? Okay, well, if the tangent equals 3/4, which quadrant am I in? You're in the first quadrant. Right? Which 2 quadrants is tangent positive in? The tangent is positive in these 2. But remember, for the purposes of inverses, for tangent, we're only looking at quadrants 1 and 4. We're limited to -π/2 to π/2. Same for sine, -π/2 to π/2. Remember that each one of these, unless you limit the domain, it doesn't have an inverse because it would fail a horizontal line test. Right? Look, sine and cosine, you know, if I use the whole function, would fail a horizontal line test, therefore no inverse. So that's why we have to, for inverses, we would never get an answer that is outside of these two quadrants. So in this case, the tangent is positive, it's 3/4, so we'll go 3, draw a triangle, the angle is with the x-axis, tangent is 3/4, so it's opposite over adjacent. Use Pythagorean theorem to find the third side, and then answer the question, what is the sign? In this triangle, what is the sign? Opposite over hypotenuse, 3/5. I mean, they even say right there, draw a picture. Draw a right triangle and set it up that way. 25 to 38. Okay, this is the section. You know, there's a lot of problems in there, and they're like solving trig equations. There's a lot of different ways you could solve them, right? We're not interested in, we're not going to be able to go through every way we did that. But for example, the reason I picked these problems, because there's more. There was more above that. I think there was more afterwards. But on the test, it definitely says in the interval 0 to 2 pi. So I was just trying to pick the ones that had that same kind of direction to it. So, for example, the cosine, this first one, cosine to the third x equals cosine x. Do you remember how we attacked that? Did we divide by cosine? Why not? Because cosine x could be 0, and then you'd be dividing by 0. Right? So we can't do that. So instead we get everything on one side, 0 on the other. Right? And whenever you do that, why do you do that? Whenever you get everything on one side, 0 on the other, what are you always going to do next? Factor. Right? You're trying to put it in the form where you can use zero product property and then set each factor equal to 0. So the first step is to get everything on one side, 0 on the other. The next step is to factor. In this case, factor out of cosine x. And then cosine squared x minus 1 could be factored too. That's a difference of squares. Cosine x times cosine x plus 1 times cosine x minus 1 equals 0. Right? So we factor it, and now if this product equals 0, that means that one of these factors equals 0. So what value of x would make the cosine of x equal to 0? Again, I draw the unit circle because that's where I figured these things out. You know, where is the cosine equal to 0? Pi over 2, 3 pi over 2, right? So it said between 0 and 2 pi, so not negative pi over 2, right? That wouldn't be right. So this one we'd say x equals pi over 2, 3 pi over 2. When is it that cosine x equals negative 1? Where in here does cosine equal negative 1? Pi. And then where is it that cosine x equals 1? Right there, right? Now, what are you going to name? What value are you going to get for x at that point? Okay, this is where you got to notice. 2 pi is not in the interval. That's a round parenthesis on 2 pi. It means 0 is included, 2 pi is not, so you would have to say 0. So you could see like this one here, add 1 to the other side, take the square root of both sides. Then secant turns into, you could flip it, become a cosine, that kind of thing. Okay, now the last two sections are all about the law of sines, the law of cosines, which you will be given on the test. Right? You have those going. Remember, and this first page here, page 408, that was the law of sines. So remember, we use law of sines to solve angle, side, angle, 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 side, and side, side, angle. And if you remember, the law of sines is the sine of A over A equals the sine of B over B equals the sine of C over C. You know, you have to have one side and opposite angle, and then you can solve your triangle. These two end up being more or less the same thing, because if you know two angles in a triangle, you can always find the third. So in the end, these two will end up being AAAS, right? You will have three angles if you've got two angles. And those are pretty straightforward. And some of these up here, you could see are like that. Like this ACA, that has got to be angle, angle, side. Right? It's not the included side, so it's angle, angle, side. I think they have some down here, like here's a BCA. There's an angle, 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 side, angle. So try some of each to make sure. They're very straightforward. There was never a time when we got no solution or something like that. The side-side angle, that was the one that you could get two triangles, you could get no triangles, or you could just get one triangle. On the test, it's not. It's a pretty straightforward problem. That's why these problems are not from the sections that was about the possibility of getting two triangles. But still, you have to know how to plug in for law of sines. Right. And then what were the two situations we solved with the law of cosines? Side, 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 and side, angle, side. So you should try to pick some out that are each one. Make sure you know how to do it. You know, you'll be given the formulas for it. So that's all the third 9-week stuff. Right? Then we get into the fourth 9 weeks. And it's going to be a little bit disjointed, because when we did this, we did vectors first from the end of chapter 6, and then we jumped down to chapter 11. But I just put it in order of the pages, so we'll get back to it. You know, the first thing when we first started dealing with vectors, it was how do you find the component form of a vector if you know the initial point and the terminal point? Again? Subtract terminal minus initial, right? This first one would be 5 minus negative 3, 8. 1 minus negative 5, 6. And you use those angle brackets like that to indicate this is a vector. And then how do you find the magnitude? If you have a component form of a vector, how do you find the magnitude? I mean, so remember, if I graph this, if I graph, let's say, the directed line segment of 8, 6, that would look like this, right? Here's 8 and here's 6. So it would look like that. That's the vector. The magnitude is the length of the vector. Well, how are you going to find the length of the vector if you know the component form? Right? This side here, right, is going to be the square root of 6 squared plus 8 squared. I mean, it's Pythagorean theorem or distance formula, whatever way you want to call it. Remember, a vector has both size and direction, right? The size of it is called the magnitude. And they didn't even say it, but in this case it would be 10. And so you would say the magnitude with these double, it kind of looks like double absolute value symbols. How do you find a unit vector? Let's say I wanted to find the unit vector for number 42, a unit vector in the same direction as vector v. You divide it by its magnitude, right? So you're going to say the vector divided by the magnitude. In this case, the magnitude is going to be 13. So that'll be 5 negative 12 over 13. So 5 over 13, negative 12 over 13. That would be a unit vector. Now, on the test, it's not going to say, now verify your answer. That's just part of the directions here in this problem. I mean, it's not a bad idea. It's like just saying, check your answer. Okay, how do we find the angle between two vectors? You have a formula. You need to know the formula. Not given. Cosine of theta, u dotted with v, over the magnitude of u times the magnitude of v. What do we mean by u dot v? It's a dot product, right? And how do you do the dot product between two vectors? So in this one right here, right, u dot v equals 3 times 4 plus 2 times 0. Right? It's this times this plus this times this. 12. So that's what would have gone there. And then the magnitude of u and the magnitude of v, we just figured out. We just showed how you do magnitudes. Right? All of that would be the cosine of theta. Okay, so then what do you have to do to actually find the theta? Cosine inverse. Okay? Now, on the test, usually you do an angle between vectors like that. That's degrees. So make sure you're in the right mode. If you're not in the right mode and it's multiple choice, you're going to be looking at it going, I don't see my answer. Hopefully that'll prompt you to say, that's right, I got to be in degree mode. Okay. Okay, then we get to the conic sections. Like I said, we'll get back to the vector stuff in a minute. But in the conic sections, this one is for a parabola. Can you tell by looking at something like this? What is the vertex? What is the direction of opening? The distance from the vertex to the focus, all that kind of stuff. I mean, are these in standard form? Let's say these two right here, are they in standard form? Remember, the standard form is solved for the squared term. So if there's anything with the squared term, you got to get it onto the other side. So this one here would have been x minus 1 squared equals negative 8 y plus 2. Right, so what is the vertex of this parabola? Positive 1, negative 2. Okay, does it open up, down, left, or right? Okay, because it's y equals x squared, it's either up or down. Because that's negative, it's down. Okay, and what is the distance? If I drew this, let's say 1, negative 2 would give us 1, negative 2. We know that it opens down. How can I figure where down here does the focus go? Okay, this here is 4 times p. And p is the distance from the vertex to the focus, from the vertex to the directrix. Right? So in this case, p equals negative 2. So we would go down 2 and up 2. And remember, the focus is a point. The directrix is a line. Y equals 0. I picked these problems out because the one you get on the test is also in pretty much this form. You don't have to complete the square on it, right? That part's already done. It's pretty much, it's either in standard form or maybe it's like this. You just have to move some things to the other side. That's it. Now, the question about the ellipse, it's not in standard form. Right? You do have to put it in the standard form by completing the square. So let's remember how we complete the square. let's say, if we want to just do, I'm going to do the number 44. Okay, number 44. So remember, the standard form for an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. Although that's just one variety, right? It could be that the a squared is there and the b squared is there. But in any case, we need to get, create perfect squared trinomials so that we can put them in parentheses with a squared outside and make sure that there's a 1 on the other side, right? So on this one right here, that was the one, right? 44. First, we get together the x terms, right? 3x squared plus 18x. Then we get together the y terms, y squared minus 2y. And then we make the constant, put the constant over to the other side, add 8. Okay, now we can't complete the square if there's a coefficient on the squared term. You have to factor it from those two terms. So factor that out, x squared plus 6x. Leave a space for completing the square. And then this one, no problem. It's 1y squared, so we can deal with that one right away. Right, how do I figure what do I put here? Half of 6 is 3. 3 squared is 9. Okay, what do I have to add to the other side to balance what I just did? Okay, because there's a 3 outside parentheses, I got to add 3 times 9, 27. Right, now I don't have the same problem here because it's 1, right? So I add 1 there, and I add 1 there. So this is 3 times x plus 3 squared plus y minus 1 squared equals 35, 36. Okay, now that's not quite in this form, so what do I have to do now? Divide by 36, right? To make the 1 there, divide by 36. But since there's a 3 there, that'll be x plus 3 squared over 12 plus y minus 1 squared over 36 equals 1. So I don't remember the question exactly, but it'll be something like, find the vertices, find the foci, find the center, something like that. Well, you can't really tell that until you put it into that form. Okay. So remember how to complete the square on that. Okay, so there is a question that has to do with the asymptotes of a hyperbola. And it's given something that's pretty much in this kind of form. You don't have to complete the square or anything. It's in a standard form. I believe it's like this, where the center is 0, 0. But you have to answer a question about the asymptotes. Remember the way that it works when we graph a hyperbola. Let's make sure these people are here. Not here. Right. So let's say I'm going to do this one right here. What is the center? X minus 0 squared, y minus 0 squared, 0, 0, right? So there's the center. Is it a horizontal transverse axis or a vertical transverse axis? Okay, it is horizontal because the first term is x. The first term, the positive term is x. It's horizontal, right? So we would know that we're supposed to go square root of 9, 3 to the left, and 3 to the right. Those are the vertices, right, of each branch of the hyperbola. Then we would go square root of 25, 5 up, 5 down. And these are going to be the midpoints of the sides of a rectangular box. Okay, why did we draw that box? So that we can sketch in the diagonals of the box, and the diagonals are the asymptotes, right? So we know that this is a vertex, which means that the hyperbola starts there, and then it would veer off towards approach the asymptotes without ever touching. Done. So the question is about the asymptotes. What's the equation of these two lines? I mean, remember, the equation of a line is generally y equals mx plus b. Or in fact, it's better to even to do it this way. Y minus k equals m times x minus h. It's point slope form. And in this case, the hk is 0, 0. So, in fact, it's plus or minus m, because one line is plus and one line is minus. And then you could tell in this case, just looking at it, that the slope is up 5, right 3, 5/3. Okay. In this case, that happens to be the b divided by a. But I mean, if you sketch the graphs, you should be able to see what the slope is. I mean, if you drew the rectangle. So this slope is either a over b or b over a, depending on whether it's horizontal or vertical. Okay, then classify, right? Be able to, if you're looking at the general second degree equation here, be able to classify as circle, parabola, ellipse, hyperbola. Right? How did we recognize which of these is a parabola? One squared term. Okay, so looking at this list, how many parabolas do you see? 56 and 59. Okay, how would you recognize a hyperbola? One's positive, one's negative, right? So which ones of these are hyperbola? 55, 57, and that's it. Okay, so now we're left with circles and ellipses, right? How do you recognize a circle? They're the same coefficients, right? So this one is a circle, that's a circle, and that's it. And then what's left? Unequal coefficients. Same sign, but not equal. Ellipse. Ellipse. These problems here, parametric equations. So remember, what are parametric equations? Right? When both x and y are functions of a third variable, the third variable is called a parameter. And these equations are called parametric equations. So we should know something about the graphs. I mean, I would go back and look at some of our examples of graphs. I don't want to be too specific about it, but you need to know how the shapes of the graphs sometimes look. And then what do we mean by eliminating the parameter? Say what? Remove the t. I mean, the parameter is t. So if you want to eliminate the t, you have to solve one of them for t and then plug it into the other. For example, let's say I did number 13. To eliminate the parameter, I would solve for t. T equals x minus 2, and then I'm plugging that in here. Y equals x minus 2 squared plus 2. Oh, that's wrong. Sorry. It's just x minus 2 squared. I believe there's two questions. One is definitely eliminate the parameter. Another one just has to do with shape of a graph. Polar coordinates, right? Plot a point in polar coordinates and then find additional polar representations of the point. Okay, so for example, if I was going to graph this point here, right? That point would be 2. Oh, what am I doing? mean, that point is the r and theta, right? So r is telling us how far away are we from not the origin, but the pole. And we did this by drawing these concentric circles, right? The one that had a radius of 2, we knew the point would be there. The theta is telling us the angle with the positive x-axis. So where do we find 5 pi over 6? That's the unit circle value, right? 5 pi over 6 is here. So if I went 5 pi over 6, at a radius of 2, then that would be the point. Okay, now in between 0 and negative 2 pi and 2 pi, how can I find other representations for the same point? How could I find the coterminal angle between negative 2 pi and 0? Subtract 2 pi, right? Subtract means go this way. So essentially you would get, what is this angle here? If you go in a negative direction, how would you have called that angle? Negative 7 pi over 6. Right? I mean, 7 pi over 6 is to go pi over 6 beyond, right? So we're going to go negative 7 pi over 6. So we could say this is 2 negative 7 pi over 6. Okay, and then what was the other way that we came up with representations? It was a little tricky. It involved negative radius. How is it you graph a negative radius? Right? A negative radius means instead of going off in this direction, pi over 6, we're going to go in this direction. This is negative pi over 6 as an angle, right? But since the radius is negative, we're not going that direction. We're going in the opposite direction. Let's see. So that would be negative pi over 6. Or it could have been negative 2. What would be the positive angle going from here around to here? On the unit circle, what's the positive angle? 11 pi over 6. So you could either have 2 or negative 2, just depends on whether you're going off in that direction or you're going off in that direction. Okay, so now we get into the second part of vectors. What is this U cross V? When you do what? No. That's not scalar multiplication. What's scalar multiplication? Scalar multiplication is if I multiply 1, negative 1, 0 by a number, 5, right? That's a scalar. Cross product, the cross product of 2 vectors is another vector. What do we know about that vector? The cross product is orthogonal to the first 2. What do we mean by orthogonal? What are orthogonal vectors? Yeah, with lines you'd call them perpendicular, meet at 90 degrees or 90 degrees between them, right? So by orthogonal, that's what we mean. When you take a cross product, you find orthogonal vectors. Okay, so let's see. If I do U cross V, right, I have 1, negative 1, 0, 0, 1, negative 1. Right, I need to fill up 3 components in a vector. Remember, for the first component, you cover up the first the first component of both vectors, and then you do like a determinant of a matrix. Negative 1 times negative 1, minus 1 times 0. 1 minus 0 is 1. Okay, what about the second component? Cover up the second component. 1 times negative 1 minus 0 times 0. Right? That would be negative 1, except the middle component has got a negative in front of it, 1. And the third component, cover those up, 1 times 1, minus 0 times negative 1, 1. Right? So that's the cross product. Now, would it matter if I flip these two? I mean, if you flip those two, you don't get the same vector. You would have gotten negative 1, negative 1, negative 1. So yeah, it matters the order that you do it. So we had to do U cross V, so I wrote the U on top of the V, and then I did that thing. And then I think for the rest of this stuff, I'm not going to say much because this is the stuff we just went over, right? But you can see, at the very least, I'll say this. If you have to find the limit as x approaches c, and you can see the kind of problems that are here, notice what's not there. Rationalizing technique is not there, okay? Because that's not on the test. It's either going to be the dividing out or dividing out, direct substitution. You know, again, this whole thing about when a limit exists and doesn't, you know, whether you get it in a piecewise function, you get this same old absolute value function. What about this one here? The limit as x approaches 1 of 1 over x squared plus 1. Does it exist? I mean, is there anything that you could plug into this x there that would make the denominator equal 0? No, because since that's squared, this term will always be 0 or positive, and it's already plus 1. So actually, this thing has a limit. Just plug it in. 1 over 1 plus 1, 2, 1 half. Then using the limit process, you know, with the formula, which you're given, to do this, or to find a derivative, or to find the limit as x approaches infinity for n approaches infinity. That's pretty much it. So you put it all together. I mean, if for example, you know that the exam part of it isn't going to hurt your grades, and maybe you think, I don't want to go back and do all that trigonometry from the third 9 weeks. You could just focus on this, you know, for the one test that replaces a lower test score in the fourth 9 weeks. That's up to you too. So, as I say, it's 30 questions. The first 10 are about this. The next 20 are about this. So the first 10 and the second 10 add together to be an exam, and then all the 11 through 30 end up being that. And we meet on Tuesday, 9:55. And if you've got any kind of test or redo, retest, whatever, you know, up until Friday, I'm here every day, probably 3 o'clock, because we're done at 11:25 every day.